This chapter focuses on the essential concepts of data analytic thinking and prediction. We'll explore foundational ideas in data science that are crucial for building effective predictive models. These models are designed to help businesses make smarter, more informed decisions. Throughout this chapter, we'll break down how to approach data analytically and use predictions to solve real-world problems. Data science plays a crucial role in transforming raw business data into clear, actionable predictions. This means managers can make decisions with greater confidence, acting faster and more precisely. One of the key advantages is that data science uncovers hidden patterns in large and often messy datasets, patterns that would be difficult or impossible for people to spot on their own. By improving the accuracy of forecasts, it shifts decision-making away from guesswork to being based on likely outcomes. Ultimately, data science bridges the gap between complex analysis and real business decisions, influencing areas like pricing strategies, risk management, and how resources are allocated. This is why data science is so important for effective decision-making in any organization. On this slide, we're focusing on the partnership between the management accountant and the data scientist. The management accountant plays a crucial role by defining the decision context. They ensure that any analysis stays grounded in how the business actually operates. This means prioritizing financial data, understanding the broader business context and constraints, and ensuring compliance and controls are maintained throughout the process. Meanwhile, the data scientist complements this by building the analytical engine. They handle the technical side, designing and tuning models, performing statistical analysis, and validating predictions. Their work turns raw data into reliable forecasts and decision support tools. The key idea here is collaboration. Better predictions and more actionable insights emerge when business judgment from the accountant comes together with the data scientist's analytical methods. This partnership helps balance practical business considerations with robust, data-driven analysis, ultimately leading to smarter, more informed decisions. On this slide, we're focusing on the critical questions that drive effective predictive modeling. First, we need to identify which customers are most likely to stop buying. This helps us proactively address retention before losing valuable clients. Next, we look for signals that suggest a cost overrun before it actually occurs, enabling us to control expenses and avoid surprises. Then, we determine which transactions should be flagged for review first, prioritizing the areas with the highest risk or impact. The key takeaway here is to start with the decision, not the data. Strong predictive models don't just rely on data alone, they begin with a clear business question that management needs answered. This approach, which we refer to as data analytic thinking, ensures that predictions are both relevant and actionable, leading to better outcomes. This chapter is all about aligning analytics with real business goals from the outset. When identifying relevant data, the process begins by clearly understanding the business problem or decision we need to make. This helps us focus on what information is truly necessary for our model. We then define specific data requirements based on that problem. Internal data is crucial here. It includes things like transactions, costs, customer information, and operations. This data provides a detailed picture of how the business is running. On the other hand, external data complements this by offering insights from market signals, economic trends, and competitor actions, helping us understand the broader environment. From these raw data points, we create calculated variables such as ratios, trends, segments, and other derived features that can reveal deeper patterns or insights. This entire approach is grounded in data analytic thinking and prediction, where we use the data to inform and improve our decisions effectively. The key is to always start with the decision in mind, and then work backward to identify exactly what data is needed. This slide introduces the concept of decision trees, which are powerful tools in data analysis and prediction. At the very start, a decision tree poses one main question. This is called the root question. From there, the tree branches out into smaller decisions, each represented by binary yes or no questions, progressively splitting the data into narrower groups. These branches continue until they reach the leaves, which are the final outcomes or predictions. Essentially, every split helps us to organize and categorize our data more precisely, guiding us step by step toward a clear decision or prediction. This structure makes decision trees intuitive and effective for analytical thinking. Now, let's break down the main components of a decision tree, which are essential to understand how it works. At the very top, we have the root node. This is the starting point and represents the first, and often most important, split in our data. From there, we move to the internal nodes. These are the decision points inside the tree where further questions are asked, splitting the data based on additional rules. Connecting these nodes are the branches, which represent the possible paths that data can take based on each decision. Finally, at the end of each branch, we find the leaf nodes. These are the terminal points of the tree and provide us with the final prediction or classification based on the data. Together, these four components, root node, internal nodes, branches, and leaf nodes, form the structure that allows decision trees to analyze data and make predictions effectively. Here, we're looking at how decision trees handle data splitting to improve prediction accuracy. Before the split, the data points are mixed together, which makes it harder to predict outcomes clearly. After the split, the data divides into different branches, Branch A and Branch B, where each group is more homogeneous. This homogeneity means that the data within each branch shares more similar characteristics, making the next decisions easier and more precise. Essentially, a useful split takes one mixed group and breaks it down into smaller, more consistent groups. This approach is key to the power of decision trees in data analytic thinking and prediction. Chapter 11 focuses on the role of business context in data analytics. It's essential to refine our models based on how the business actually operates, not just on abstract data. This means we need to consider real-world factors such as capacity limits, company policies, timing constraints, and costs. By incorporating these elements, our predictions become more realistic and actionable. Domain expertise plays a crucial role here. Experts help translate these predictions into practical decisions that align with business goals. Ultimately, combining data analytic thinking with a deep understanding of the business context ensures that our insights lead to effective strategies and improvements. Here we focus on refining tree models to better fit real-world applications. Initially, the model is purely data-driven, optimizing the fit based on historical outcomes. While this approach might seem ideal statistically, it often ignores practical limits, which can make predictions less useful in actual operations. This is where the review stage becomes critical. By incorporating business context through domain reviews, we factor in cost constraints, feasibility of actions, risk tolerance, and compliance with policy or regulatory rules. These elements ensure the model aligns with real-world requirements. Next, we refine the model by adjusting splits and outcomes based on this additional insight. The result is a refined model that provides a score followed by a manual review step. This process makes approval or rejection decisions more realistic and operationally practical. Ultimately, by combining data analytic thinking with business considerations, we achieve stronger, more applicable models that not only predict accurately but also support effective decision-making in practice. Now, let's dive into the concept of validation, specifically the difference between training and test data. We start by building our model using the training data. This training data consists of historical data with known outcomes. During this phase, the model processes the data to learn patterns, splits, and relationships, ultimately resulting in a fitted decision tree that we can then test. The performance on the training data shows how well the model has learned from the sample it was given, and we evaluate this using key validation metrics like accuracy, precision, and recall. Next, we move to the test data, which is a completely separate set of unseen data that was held back during training. Here, the model makes predictions which we then compare against the actual outcomes. This test performance is crucial because it tells us if the model truly generalizes to new data or if it simply overfits the training examples. In summary, by comparing training and test data performance, we ensure that our model is reliable and effective for real-world predictions. On this slide, we focus on model evaluation, specifically 3 core metrics that help us understand different aspects of prediction quality. First, accuracy measures overall correctness. It tells us the share of all predictions the model gets right. Accuracy is particularly useful when the classes are balanced and each type of error has a similar impact. Next, precision looks at the quality of positive predictions. It answers the question, of all the instances the model predicted as positive, how many are actually positive? Precision is crucial when false positives can be costly or disruptive to the business. Finally, recall measures the coverage of true positives. It shows, out of all actual positive cases, how many the model successfully identifies. We prioritize recall when missing a true case carries a high business risk. Understanding these 3 metrics gives us a rounded view of how well our model is performing and helps us make informed decisions about improvements or trade-offs. Here we're comparing 2 types of models, the full model and the refined model. The full model uses all available splits, which means it's more complex and can capture more detailed patterns. However, this complexity comes with a higher risk of overfitting, where the model fits the training data too closely and might not perform well on new data. On the other hand, the refined model takes a more practical approach by aligning with the business context. It's constrained to make predictions that are more realistic and useful in real-world applications. While the refined model might have slightly lower accuracy compared to the full model, it's often more valuable because its predictions are constrained and actionable. Essentially, this slide highlights the trade-off between complexity and practicality in model evaluation, emphasizing the importance of balancing accuracy with the business needs to get the best overall result. Now, let's focus on model evaluation by comparing multiple models to see which performs best across key metrics. Here, we have 3 models: decision tree, random forest, and logistic regression. The most important metrics we consider are accuracy, precision, and recall, as they give us a comprehensive understanding of each model's predictive power. The decision tree model shows solid results with accuracy at 84%, precision at 81%, and recall at 79%. However, the random forest stands out as the best overall, achieving the highest scores across all metrics: 91% accuracy, 89% precision, and 88% recall. The logistic regression model performs well too, but slightly behind random forest, with accuracy at 86%, precision at 85%, and recall at 82%. This comparison highlights how random forest offers a superior balance of accuracy and reliability for making predictions in our analysis. When selecting the right model, it's crucial to start by identifying the primary business objective. If maximizing accuracy is the top priority, an ensemble model is often the best choice. These models combine multiple algorithms to deliver the most accurate predictions, but they can be complex, making them harder to explain and maintain. On the other hand, if transparency is important, a refined decision tree might be better. While it may sacrifice some accuracy compared to ensemble methods, it's much easier to interpret, which can be valuable for stakeholder trust and regulatory requirements. Sometimes, the need to move quickly outweighs other factors. In those cases, a simple baseline model is ideal. It's fast to deploy and can provide quick insights, though it might not capture complex patterns as effectively as more sophisticated models. Ultimately, the key is to balance accuracy, interpretability, and speed based on your specific needs. This approach ensures that the model you select aligns well with your business goals and practical constraints. Chapter 11 focuses on communicating model insights effectively. The key to clarity is translating complex technical results into language that everyone in the business can understand quickly. It's important to provide context by linking predictions directly to the specific decision, the underlying data, and the overall business environment. Being transparent about the model's limitations is crucial. We need to openly discuss uncertainty, assumptions, and areas where the model might be misleading. Finally, communication should always lead to actionability, ending with clear guidance on what managers should do next, rather than just presenting predictions. This approach ensures the insights truly support decision-making. When we present predictions, it's crucial to include a confidence range to show not just the expected outcome but also the uncertainty around it. This makes the forecast more credible and helps stakeholders understand the possible variations in future results. Here, we see the predicted values laid out across future periods, Q1 through Q4, highlighting the expected path of the forecast along with its confidence range. Beyond just the numbers, this view also emphasizes feature importance, showing which factors most influence the prediction. For example, customer mix accounts for 32% of the impact, price level contributes 26%, seasonality has an 18% influence, region affects 12%, and promotional spending makes up 7%. Understanding these drivers helps management focus on the key business levers that actually move the needle. The visuals are designed to be stakeholder-friendly, connecting the prediction outputs directly to actionable business insights rather than technical model details. By showing both what the model predicts and why it predicts it, we provide a clear, concise format that leaders can quickly grasp and use to make informed decisions. Now, let's dive into the key steps involved in deploying data science models effectively. First, model approval is critical. Before releasing any model, we need to confirm its accuracy, ensure it fits the business context, meets governance standards, and gains the necessary stakeholder sign-off. Without this, we risk deploying something that doesn't align with our goals or compliance requirements. Next is system integration. This step is about embedding the model directly into existing workflows, data pipelines, and decision support systems. It's essential that the model works seamlessly within the daily operations to deliver real, actionable insights. After integration, setting up monitoring is crucial. We define alerts, establish thresholds, and create dashboards to continuously watch the model's quality and usage. This allows us to detect any issues early and maintain confidence in the model's performance. Performance tracking follows closely. Here, we measure the model's predictions against actual outcomes to verify that it's delivering real business value. This ongoing verification is key to understanding impact and guiding future improvements. Finally, continuous refinement ensures the model stays relevant. Conditions change, so we must update features, retrain models, and adjust deployment strategies to maintain optimal performance over time. Altogether, this disciplined rollout sequence helps move us from just having a validated model to truly operationalizing it as a powerful business tool. Once a model is deployed, its value depends on continuous monitoring by the team. One key aspect to watch for is data drift, which happens when incoming data starts to differ significantly from the training data. This can impact the model's accuracy, so we need to track any loss in prediction reliability over time. It's also important to monitor prediction volume to understand usage patterns, such as sudden spikes or drops, which can affect operational load. Additionally, anomaly alerts play a crucial role by flagging unusual outputs early, helping us address potential issues before they impact business decisions. By staying vigilant with these monitoring practices, we ensure that our model continues to perform effectively and delivers consistent value in production. In this chapter, we focus on the crucial process of model maintenance and updates. Predictive models offer true value only when they are actively managed through continuous monitoring, improvement, validation, and redeployment. The process begins by observing the model's performance to detect any issues that might arise. Next, we investigate the root causes of these issues to understand what's affecting the model's accuracy or reliability. After pinpointing the cause, we retrain or refine the model to enhance its performance. Once changes are made, they must be thoroughly validated to ensure they positively impact outcomes without introducing new problems. Finally, the updated model is deployed, and the results are carefully monitored once again. This cycle of observe, investigate, retrain, validate, deploy, and monitor constitutes a continuous improvement cycle that is essential for keeping predictive models effective and relevant over time. When we talk about ethics in predictive modeling, several key points come into play. First, bias in data is a critical issue. Historical data often reflects past inequalities, missing information, or biased sampling, and this can lead to systematic disadvantages for certain groups or segments. It's essential for analysts to actively test their data to identify and mitigate these biases. Next, fairness in predictions is just as important as accuracy. A model might perform well overall but still generate unequal outcomes for different populations. Accountants and analysts should carefully compare error rates and the real-world impact of decisions across relevant groups to ensure fairness. Transparency is another crucial aspect. Decision-makers need to have a clear understanding of what factors influence the predictions and the limitations of the models. This means communicating the main variables, assumptions, and trade-offs before any model guides important business actions. Data privacy cannot be overlooked either. Predictive models often rely on sensitive financial, employee, or customer information. It's vital to use only the necessary data, safeguard access rigorously, and comply with all relevant policies and regulations. Ultimately, building strong predictive models is not enough on its own. The decisions we make based on these models must be fair, explainable, and responsible to truly add value in a trustworthy way. In Chapter 11, we're focusing on building a data-driven culture, which is essential for making informed decisions that really move the organization forward. One of the key points here is that leadership must back their decisions with solid evidence. When leaders prioritize data, it sets the tone for everyone else to follow suit. Another important aspect is the role of cross-functional teams. These teams help turn raw data into actionable insights by combining different perspectives and expertise. This collaboration ensures that data doesn't just sit in reports, but actually drives meaningful outcomes. Trust in the numbers is fundamental, and that comes from having shared definitions and standards. When everyone agrees on what the data represents and how it's measured, it reduces confusion and builds confidence in the results. Finally, continuous learning is critical. The environment and data evolve constantly, so models and approaches need regular updates to stay relevant and accurate. This mindset of ongoing adaptation helps organizations maintain a competitive edge through data. Overall, these elements work together to create a strong, sustainable culture centered around data and analytics. Let's discuss some key takeaways about data analytic thinking and prediction. First, creating business value begins with asking the right decision questions and using the right data to address them. Without a clear question or relevant data, even the best models won't provide useful insights. Next, collaboration is crucial. Management, accountants, and data scientists working together can build much stronger models. Each brings unique expertise that complements the other, ensuring both business relevance and technical accuracy. It's also important to remember that decision trees and other models must represent the real business context, not just statistical patterns. Models disconnected from actual business scenarios can lead to misleading conclusions. Before trusting any predictions, validating the models and comparing different approaches is essential. This step helps ensure the reliability and robustness of the insights we derive. Finally, the most effective model is one that can be clearly explained, easily deployed, and actively used in decision-making processes. A model that's too complex to understand or implement won't deliver the value we need. In this chapter, we explore the complete journey from data to action, emphasizing that a predictive workflow only delivers value when each phase seamlessly connects to the next. It all begins with asking the right questions, focusing specifically on business decisions we need to support. Next, we gather relevant data inputs, ensuring we have the information necessary to proceed. Then, we dive into exploring patterns within that data, identifying meaningful signals as well as any gaps that might exist. After uncovering these insights, we build models by training predictive algorithms to capture those patterns. But building models isn't enough. We must validate the results, testing accuracy and fit to ensure they truly reflect reality. Once confident, we communicate these insights effectively, translating complex findings into actionable recommendations. Finally, we deploy the models and continuously monitor their performance, using feedback to track improvements and make adjustments. This iterative process embodies data analytic thinking and prediction, turning raw data into informed business action. As we wrap up Chapter 11, let's take a look at the key resources and next steps to reinforce your learning. The core reading assignment focuses on review of tree refinement, validation, and model comparison examples, which are essential concepts to master for effective predictive modeling. When it comes to tools and platforms, Excel or Power BI are great for business analysis and visualization, helping you make sense of data in a clear, accessible way. For more advanced modeling and validation tasks, Python or R are powerful options that allow deeper analytical work. And when it's time to communicate insights to stakeholders, Tableau stands out as a valuable platform to create compelling visual stories. In terms of your learning path, focus on asking better business questions that drive your analysis. Always aim to match your data to the decisions that need to be made, ensuring your work is relevant and impactful. Then, build, refine, validate, and compare your models carefully. This iterative process is critical to arriving at reliable predictions. Finally, learn to deploy insights into action, turning data-driven conclusions into real business value. Remember, the goal here is to develop strong data analytic thinking and predictive skills, moving you from understanding basic concepts to delivering business-ready predictions. Use these materials, tools, and steps as your guide to continue growing and applying your knowledge effectively.